Good afternoon, everyone.
Afternoon, sir.
Afternoon to you, Alicia. All right, so I'm sharing a screen. Can you see the screen?
No, sir.
Seeing it now? Hmm.
Yes.
All right. Do me a favor. Can you just go through and just look at the different processes um, and see if what it is that you can relate to, and then we're gonna have a conversation on it. I give you I give you about 10 minutes to look through the cycle, the hydraulic cycle or the water cycle, and and we'll have a conversation. Anything that you have a question to, please feel free to ask. I will come and have a fulsome conversation as it relates to the hydrologic cycle or the water cycle. So start for me, please.
Um, sir, you can repeat that. Sir, you can repeat what you just said. You should go through the cycle.
Yeah, just look at it and see what you can relate to from the projected cycle, and then I'm going to go through the cycle with you. But I just want to give you an opportunity to see if you can look at it, see what is happening, the different stages, and see if you can relate to it. And then we're going to have a conversation about it. So I'll give you about 5 minutes, 5, 10 minutes thereabout. Just can start
Yes,
looking at it.
sir.
If you finish beforehand, just indicate and let me know so we can start the conversation. All right?
Yes, sir.
Mhm.
Sir, is it still being shared?
Yes, it is. Not seen it?
No, sir.
Look now to see if you see it.
Yes, sir.
All right,
Yes,
good, good.
sir. Sir, it can be zoomed.
I should think so. Let me try. That's good.
Yes, sir.
No problem, ma'am.
Good evening.
Evening.
All right, so you had an opportunity to look at it, or are you still looking?
Sir, I'm not seeing anything on my screen.
All right, hold on. Supposed to see it now. All right, see?
Yes, sir.
All right, I give you 3 minutes to look at it. The others you can.
Sir, so is it that what we should explain the hydraulic
Yeah,
cycle?
yeah, man. So that's what I am going to be doing for you. I'm going to do the explanation, but I wanted you to just look at it for yourself and just see what is
Wait.
happening there, and then I will
Okay.
go through the explanation, and then we can have a conversation on it.
Okay, sir.
Mhm. All right. So I would have given you enough time to have a look at that. So before I go into the specificity of what those terms mean, the precipitation, the surface runoff, the groundwater flow, the alluvium, um, the discharge into streams, evaporation, transpiration, evapotranspiration. We,
Oh,
we
sir, it's gone again. Can you share again?
I'm still sharing it now. It's just that maybe I have a break. Are you seeing it now?
Yes, sir.
Yeah, good. So
Sir, are you saying something?
Hello, sir, are you speaking?
Going in circles. Up top.
Thank you, Mr. Johnson.
Let me clear my room, nothing here. Okay.
My apologies, sir started to speak. Sir was speaking.
I don't know, I was asking the same thing.
Okay.
This thing has no behavior. What was the last thing you heard, guys? Because I'm here talking to myself.
No, we didn't hear anything.
Same thing. So my eyes were closed. I was talking to you. And when I opened it, I recognized that I'm gone. So let's go again. The moral of the story, keep your eyes open. I think the screen was just too bright and it was shining at me. Let me just turn it down. Oh no, that's a volume. Smart. All right, there you go. All right, let me see if I can reshare my screen now for you so that you can have a look at it. So I was saying to you, um, let me see if I can start. All right, let me go again. So the water cycle. Water cycle. It is also called the hydrologic cycle. And hydro means water. Hydrology, hydrosphere, anything that says hydro, it deals with water. And um, and this water cycle involves a continuous circulation of water within the earth and the atmospheric system. There are many processes, and you can see them, many processes that are involved in the water cycle. Many processes that are involved in the water cycle. But one can argue that the most important ones are evaporation, um, transpiration,
Precipitation.
precipitation, yes, condensation, um, um, and runoff.
Infiltration too.
Right, right. Those are very important um, to the whole process. Now, the total amount of water within the cycle remains essentially constant, right? So the amount of water in the water cycle is constant. However, it is the distribution among the various processes that is going to continuously change. So, for example, you have $100. You know you only have $100, but today you may spend 50 cents on food, 20 cents on light, and you have 30 cents for your disposal. The next month you decide, say, no, you're going to conserve on light, so you spend 20 cents on light, but we have the distribution right across, right? So we have distributions. Um, so the water within the water system is relatively constant. What differs is how it is that the water is distributed. Runoff, evaporation, transpiration, evapotranspiration, this, that, so forth and so on. All right. So Evaporation is one of the major processes in the water cycle. Evaporation is one of the major processes in the water cycle. And and when you look at it, when you look at it, it is water from the figure here. It is water moving from streams and our lakes. So you understand why our streams and our lakes are very important, extremely important. So it is really the transfer of water from the surface of the earth to the atmosphere. So it's a transfer of water from the surface of the earth to the atmosphere. Hold on a minute, please. My computer needs to charge. Can you pray about something? All right. Okay, good. So the evaporation, very important stuff. It moves water from the surface of the earth to the atmosphere. Now, if we don't have any water on the surface of the earth, there is no water that can be moved to the atmosphere. So our rivers and streams and our lakes are very important to the whole hydrologic cycle. Very important. Um, Evaporation is really the transfer of, by the way, I should ask you, what is evaporation?
Or the process from, oh, sorry. No, Dodin, you were answering.
Oh, yeah, I tried to talk. I was saying that it would be the removal of water or moisture from the surface of the earth here.
From liquid to gas.
From a liquid state to a gaseous state. Very good. So that is important. From a liquid state to a gaseous state. So yes, so it's actually the transfer of the water from the surface of the earth to the atmosphere. But the water on the surface of the earth is liquid. And the process by moving it to the atmosphere is going to be in a gaseous state. So just remember, evaporation is from liquid to gas, right? Or the vapor state, right? Or the vapor state. Now, especially if the time is hot, if the time is hot, when I say hot, I mean, I would have had in recent times, very recent times, very good wash days. The moment you put the clothes on the line, them dry because the time is so hot, as opposed to other days when you wonder if you should really wash because the skies kind of look black. And the moment you put the clothes on the line, that's the time it starts seeing a little, drop of water. The atmosphere is cooler. You have a lot of water vapor in the atmosphere, so the clothes takes longer to dry, right? So if on a sunny day, if you extract as much water from your laundry and put it out within half an hour, those clothes will be dry. But if on a bleaky day where you have lots of water vapor in the atmosphere, that half an hour will take about 2 hours even for your clothes to be dry. All right. So a good wash day is a day when it is really very, very, very sunny. All right. Everybody can agree with that and identify with that?
Yes, sir.
Mm-hmm. All right. So this transfer of the liquid state to the gaseous state really occurs when some of the molecules in the mass of water really gain some kinetic energy. You remember I keep saying to you that kinetic energy is the energy in motion.
Yes,
Kinetic
sir.
energy is the energy in motion, right? And potential energy is the energy at rest. So when I say to you, you have the potential to do so much more than what it is that you're giving to me, it means that you are actually, your energy is at rest. You have not yet started working. It means that you have so much more to give because you have stored up energy, stored up energy. All right. But when your body's in motion, you exhibit what we call kinetic energy. And that kinetic energy is energy that is in motion. The other one is energy at rest. All right. So um, I'm going to have that built up kinetic energy that will cause these water molecules to pretty much eject themselves from the water surface, right? In an upward position, so it is that it can evaporate, right? So think about it. It's really the heat that is, causing the movement of these water molecules from the liquid state into the gaseous state. So it is there, but the water on the surface it gets so hot. And because it gets so hot, because it's absorbing the heat, and remember, heat is coming from two ways, heat coming from two ways. Heat coming from the sun and heat coming from bedrock. Hello, why think we have the earthquake the other day? Mm?
Are you asking?
Yes, sir. Very
Yes,
hot.
it's
Mm-hmm.
very hot. Yeah, very hot, extremely hot, extremely hot, right? So, so this kinetic energy causes the water vapor it gets the water on the surface of, say, the ocean or a puddle of water. It's a smaller body. So what happens? It gains that kinetic energy, and the water molecule at the surface, because the kinetic energy has increased because of the temperature, the increase in temperature, um, the water molecules become very active, very erratic, which is the word I'm looking for. Very erratic. Now, with its great enthusiasm, and the water molecules are moving, it so happens that it drums out from the surface of the liquid and gets into the atmosphere, and there's no turning back from there. So that's exactly what happens. That's exactly what happens. Evaporation takes place on the surface of the water. Boiling, on the other hand, takes place throughout the liquid. So the water not going to boil on the surface alone. The water is boiling throughout the liquid. Evaporation takes place on the surface. So evaporation does not take place in the middle of the water. So if you have a pot of water boiling, evaporation will take place from the surface of the liquid, from the surface of the liquid, whereas boiling will take place throughout the liquid. Question. Any questions so far? Am I clear?
Well,
No,
yes,
it's
sir.
clear. Yes, sir.
Mm-hmm. Somebody said, sir?
No, sir.
Okay, all right, got it. All right, nice. Now, there are some factors that will affect evaporation. A few of them, as a matter of fact, that will affect evaporation. One of the things that I will say to you, though, is that if I have a petri dish that is filled with water, I have two petri dishes filled with water. I put one, uh, I put one at the outside of the Eagle bookstore. I put one inside of the female bathroom, and I put one in front of your house, directly in front of your house, which of the three you think will evaporate quicker?
Oh, sir, can you repeat that? It went out.
Or I'm just saying, if I have 3 petri dish filled with water, and I'm placing one at the foot, say just outside Sangsters, you know that little step that you move up from block B to go over to Sangsters, about 4 flights, where
So
the
you're
gas tank
talking
is.
at the school?
The
Yeah,
King's, the
man.
bookshop
Yeah,
at the
man.
school.
Yeah,
Okay.
man. Hmm. You put one of the petri dish right there. In the real sonnet, you put one of the petri dish right there.
Right, sir.
And then you can take another petri dish and put it, say, where the water fountain is, in the quadrangle next to students affairs under a tree. And
Mm-hmm.
then the other one you can put in the biolab, on the countertop. My question to you, which one do you think is going to evaporate first?
The one close to the bookshop.
The one close to the bookshop. Which one do
Bookshop.
you think which one do you think is second?
Um, Probably under the tree,
Okay, and which one
still in the
last?
open. The one in
Right.
the lab.
Very good. Excellent. And your choices would be correct, because there are some factors that
With the
are
lab
that
ones.
the lab one will evaporate, but it will evaporate last.
Yeah, that's what happened.
Right. And especially if you have an air conditioned unit or even the fan
Right.
going, because the fan going there, even though it's warm in there, the fan is actually circulating, so it's getting cooler. So when the temperature of the water starts to increase and the fan breeze catch it, it just say, go easy, man, and chillax yourself. What a little
Like,
five.
kind of
All
get
right.
humid. Mm.
Mm-hmm. All right. I didn't know, something just came to mind and I'm going to say it. Forgive me, but I'm going to say it. Think of you cooking curried goat. And if you put the curried goat in your car, lock up, the gravy got turn up nice, nice, nice. But you ever put it on your counter in the kitchen, I see it quail up. Talk truth.
True.
Yeah, man, it quail up because of the different factors that will affect it, right? So let us see if we can have a conversation on the factors affecting evaporation.
So the heat from the car will.
Yes, I. So we have research conference that started today. So I was on campus today for the opening ceremony. I was also moderating one of the sessions, and I left one of my protein shakes in the car. And I did it deliberately. And you know what I did? I opened the handrest compartment and dropped something in there. And inside of it, it's covered with lots of paper towel, because I have lots of hand towel inside there. It's when I got into the car and I was feeling a little peckish, and I said, you know what? I travel with it so that when I feel a little peckish, I can just munch on something until I get home. When I opened something, it's as if it was on the fire boiling. It hot, it hot, it hot, and of course, me crave me drink it same way, right? So even though it's in the car, the temperature in the car, oh my goodness. And this is why the little babies, I don't understand how adults can leave the house with 3 pitney and take out one and leave the other two in the car to die. It is beyond me. It is beyond me. But that's another conversation. Let us look at the factors. Temperature, which is what I was developing. Temperature, temperature, temperature. J's and P's. The temperature is a critical factor affecting evaporation. Humidity is another one. You remember I said to you that sometimes I wash your clothes on a Saturday, and you have um, it looks bleak outside. The clothes are gonna take longer to dry, don't it?
Mm-hmm.
Yeah, but it's humid, right? You have wind speed again, that is going to be um, a factor. So if you have lots of wind, say it is not sunny, but you have lots of wind, do you think your clothes will dry still?
Yes, or
Yes.
Yes, I.
like it die faster.
It dry faster. I was about to say that. It dries faster. And what it does also, the sun burn out your clothes.
Right. It's
But
just
the
that
wind,
when you pick it up, that kind of cold.
it go kind of cold. Yes, it go kind
Mhm.
of cold. But that's fine. You can deal with the coldness because the color will stay longer in your clothes than when you put it in the sun and make the sun. And if you're like me, when we take out my clothes off of the line, it's supposed to hot.
Yes, and fold it and put it in the drawer. Yep.
And you fold it same time.
Yeah.
You can't put it down because it go crush. And when
Yes.
it crush this so, or when you press it, it's still gonna have the crease in there. So my clothes
Mm-hmm.
off it. So sometimes I don't need 2 hours on the line, but it take 2 hours going. But maybe it's supposed to hot, crisp, and I just fold it
Mm-hmm.
same time and just put it away. I am good to go. All right.
Mhm.
Now, and the solar radiation is another variation. Um, that will affect the whole business of evaporation. All right. So um, you know what is difficult? Hmm. Evaporation in Jamaica is definitely going to be the same time as evaporation in London. True or false?
It's going to be the same time, sir?
Yeah.
I'm
No,
not thinking that's true.
Why?
sir,
The
because voltage
climate
levels,
and the temperature. Mhm.
as well as ours are here, because when we're sleeping, they're up. And if the
Mm.
sun comes out at that time, then it's night for us, so you wouldn't have any evaporation going on.
Let me ask you a question. Have you ever experienced sun hot, but it's still cold?
Huh?
Yes. Yes.
I have. I have. Sun a shine, but it cold, it
Christmas.
cold, it cold, it cold, it cold, it cold, it cold. Jesus and Father. And that's why God made me born in Jamaica. And God knew me before I was born. He knew
Mhm.
I could not survive like that. Same say, no, my child, you are for the tropical climate. No,
Mhm.
D. Him said, no. Him say, you're for doing matter of fact. Nothing not gonna make you born away. You say, no, you're jam down. Jam down.
Mhm.
Yeah. So I'm saying to you, the temperature, if I were to compare both, the temperature in London, whether or not it's a sunny day, because the atmosphere is much cooler, evaporation is going to be at a slower rate than even in Jamaica. So even if I put that petri dish in the lab, chances are it will evaporate quicker than a petri dish outside in the open in London because the temperature is so much cooler, so much cooler. All right. So just remember that some of the factors that affect um, evaporation. So now, so
So,
location is important.
is the solar radiation, temperature, and what else?
Wind, wind speed, humidity.
Yes.
All right. So the main source of direct evaporation um, or the water vapor from evaporation is really from the open source, the oceans rather, right? So the main source of water for evaporation is our ocean, and we can agree with that because the ocean is really very massive, don't it?
Yes, sir.
Yes,
Very
sir.
massive, very very massive. So you'll have the water vapor coming from that source. But guess what? That's the main source. But evaporation also occurs in soil, in snow and ice, right? Um, so if you ask me about evaporation from snow and ice, it is going to be the conversion from a solid state to the vapor state. What process is that one? When I
Sublimation.
move sublimation, very good, right? So we have evaporation, when the liquid moves and turns directly into our gaseous state. But we're gonna have those states where it's gonna move from a solid directly to a gas. Think of dry ice. Hey, what am I telling you? God protecting people, them, When I say God protect his people, I say God protect his people. Nowadays scientists and nowadays young people, them swear to them brighter than people of the past. Oh, you have to be careful because you can't eat raw egg because of the salmonella and what is going to happen to you and this and that, and ensure that it is properly cooked and you have to cook it to this particular temperature. Hey, how many of you, whilst growing up, and your mommy or your daddy or your auntie, uncle, who it is, and mix up the Christmas cake batter
I have
and
it.
you have it under the table and you lick it out? Anything I'm to uno?
No.
Yes, sir.
Well, me used to do me used to just wait until them pour it out in the container. You see, like all the glass, the measuring glass something them have in the
Yes.
kitchen with them pour. Yeah, man. Me used to help them dip it in
Mhm.
the mixture and pour it into the baking tin. And when it finished now, me go under the table, me and Jesus. And I lick,
Mhm.
I lick, I lick, I lick till it done. Then I have to wash the container. They come, it don't clean it. And I'm going to tell you, nothing happens to me. Not a thing. But nowadays, and nowadays doctors, oh, you can't because salmonella poisoning and you have to go do this and you have to go do that. Okay, well, go do it. Not now happen to me, right? But
Mhm.
dry ice. What is dry ice? What's the constituent of dry ice? Anybody knows?
Okay.
It's carbon dioxide.
Yeah, that, yeah.
It's carbon dioxide. But you know what a boy I used to do? When Fudgy coming up, I was one of those nice, respectable young men
That
growing up.
burn for real?
It sure does. And I was one of those nice, respectable young men. The Jamaican people say immanazable.
Mm.
Yeah, man. Me full of manners. Come here, mother always say, me say, yeah, manners take you through the world, my boy. So me full of manners. So you see, when Fudgy come, if me
Mhm.
ask Fudgy for anything, Fudgy go say, you always respectful. You want dry ice? And Fudgy used to know, so when him come to my yard, he must go in the back of him something. And I forgot to take out several dry ice. Then can't hold it in him hand too long, it burn.
Mhm.
But Fudgy better make sure say him take out my dry ice without me asking. And I kind of feel away, but I'm going to tell you the truth. So what I used to do when Fudgy gone now, me used to go tear a book leaf and wrap up the
Gonna
dry
make
ice
fire.
and go
Smoke.
pretend to be a smoke. And then sometimes I'm gonna do, me put the dry ice into my mouth
Yes, man.
and then blow out the something. Me Jesus, dangerous,
Mhm.
because you're inhaling all of that carbon dioxide.
The best thing ever.
But the things that we know now,
Hmm.
trust me, it will prevent it is going to prevent us from exploring and doing the things that one used to do when you're a child. Because the
Mhm.
truth of the matter is, but then again, in a today day and age now, with COVID, I will probably inhale back our own breath.
True.
Right.
You understand? So, and that's why sometimes people feel so sluggish because there's way too much carbon dioxide that is built up into your system. So the moment you move your mask and you stretch and you yawn, you are somewhat revived, right? So that's what that portion is. All right. Any questions so far? Are you following?
Yes, sir.
Yeah, man. So moving directly from a solid to a vapor, it's known as sublimation, and that's exactly what happens. So it is melting, but so you notice when ice are gone with the business and the temperature on the outside is greater than the temperature on the inside, the ice begins to melt, and you can see some vapors are go up. Talk truth.
Mhm.
You know what is true? um just look at on television or YouTube where you may see them plowing or blowing away the snow, and you can see like a mist in the atmosphere. That's what is happening, you know. It's a
Or
trans.
sir, what about sorry to cut you. What
That's
about like when you wake up in the morning
yes,
and you
I.
come out, especially
Yes,
in the
I.
rural areas, you come
Yes,
out.
I start talk.
Yes, or me didn't
Mhm,
use the same smoking thing.
mhm. To explain what is, oh dear, explain what is happening right there.
The liquid in
Anybody?
your mouth, the gas?
Mm-hmm. Because remember, the temperature in your breath, in your mouth,
Warm. Yeah.
is warmer, right? It's warmer. Um, there are times I'm on social media and I will see when people are trying to give us an idea of how cold the place is, and they will go and boil water, and they will show you the video of the water being boiled.
Mhm.
They will remove the pot from the stove, and you can literally see the bubbles still moving in the pot. Because remember, I tell you that boiling takes place throughout the liquid, whereas evaporation takes place at the surface of the liquid. And they will open their door and they go outside and they throw the hot
Oh,
boiling
it's
water
turn ice.
in the atmosphere. And what happens?
Turn ice.
Yeah, ice come down.
Sir, just
No,
stop with your screen, please. Picture
yeah,
down.
it on. Yeah, that's what I normally do. I just stop it and it comes back.
No, thanks.
Yeah, man, cool. So, um, and that's why I'm convinced that Father Jesus never did want me born anywhere but Jamaica because I couldn't deal with that. Couldn't. All right. So you just have to be very careful and remember the difference of the evaporation and boiling and sublimation. All right. Transpiration now. Transpiration is going to be the evaporation of water through minute pores, and sometimes they are also called the stomata from the leaves of plants. Right. So transpiration is very important. Now let me tell you something. When you water in the plants, don't just water at the roots here because the leaves have pores too, and them. You ever thirsty yet, and you can't wait until you get the water. You just a gulp it down. Oh,
Yes, sir.
man, yeah. I saw the leaf. Them want the water too, and sometimes the soil is so dry that by the time you wet it, the poor leaves them don't get as much as they want because the water that goes into the to the roots dissolves some nutrients and it travels up, but you're losing some of the water. So you know what I do? I have like I buy plants and I put plants in my planter box, and it's one of my responsibilities. I just love, and especially flowering plants. You know, the ones that send out nice, beautiful blooms. Oh yeah, I will spend a few dollars really, you know, to acquire some of those. So when I'm watering, I water the root, but I also
The
have a spray
leaves.
bottle and I spray the leaves.
Mm-hmm.
I spray the leaves with water because guess what? Not only that I'm cleaning the leaves, but the pores
Yeah.
from the leaves itself. Yeah, man, I drink enough water. And when I do that, I recognize that the plant is luscious. It just grateful. And I'm just thinking that boy, when the plants see me come in the water bucket, I'm supposed to say, "Yay, food time!" Because it is important. So transpiration is really the evaporation of water through minute pores, right? In the leaves of our plants. All right.
So is that the same thing as evapotranspiration?
Yes, ma'am. We're gonna go to that now. Very good. All right. So, for example, so for like the practical purposes, transpiration and evaporation from all water, soil, snow, ice, vegetation, and every bit of surface are lumped together and called evapotranspiration, which is the same thing as you do. Transfer evaporation, evapotranspiration. Or we can call it total evaporation. All right? So it's important. Because remember, when it rains, And not just the root of the water, not just the root get watered, the leaves get watered and everything. Case in point. Case in point. So I don't know. I'm a little strange. I have some very strange tendencies when it comes on to the environment. As I told you before, my peels, I drink a lot of tea. So between classes, I'm going to make tea and sip, in short order. Within about half an hour, I'm gone to put on my kettle. So you would suspect that quite a number of tea bags are bought. And I love sexy teas, right? So, you know, caramel this or coconut that, and, it's me on the stuff. And I just love teas. What's the point? It's when I finish with those tea bags, because those tea bags are actually grounded leaves of could be soursop, and it could be peppermint if I'm drinking mint, and it could be from other
Can you
things.
put it back at the soil?
Absolutely, absolutely. My orange peel, my banana peels, every peel, it is there. So one of the things that I'm in the process of doing now, the only reason I don't do it yet, it is because um we I had, when was it? In Easter, I think it was, we bought um the unshelled gungo and shelled them at home, and then threw the shell of the gungo
You know, that is what my mommy did. I have a little tree now growing.
absolutely. It's just a little tree that you have. We end up with quite a number of gungo trees, to the point where it doesn't bear a whole lot, but whenever
Yeah.
it bears, we pick the gungo and we just harvest it. We have a Ziploc in the freezer, and if we get a handful of gungo this time around, we put it down until we're able to fill up a Ziploc bag where we can get a good serving to cook from, right? So the only reason I don't turn the soil is because where I put it is right at the roots of the banana, and we have quite a number of gungo plants coming up, and I don't want to disturb them. So I'm going to wait until those plants get a little bigger. Then I go and actually turn the soil, because what it does, they actually add nutrients to the soil. So all of my tea bags, best believe that's not going down. My point though is, so my washing machine, I'm very sorry. What your teacher did, that extract hose, he went and bought an extra one. And what he did was to fuse them together. So the hose from the washing machine now is long enough that when the machine is extracting, me stand up with the hose out the door, and I'm watering my bananas, and I'm watering my coconut, and I'm watering the soursop, and I'm just irrigating the place. And I'm gonna tell you, the bananas were luscious, the leaves were
Yeah.
big. I mean, the form a nice piece of shade, to the point where at some point in time I used to put a chair and sit under the banana trees, because they were so luscious, until I I stopped doing that and decided to harvest the water itself. So I mean, I have a big container, a drum, that when the machine is extracting, all the water goes there, and then no, I decide where I'm going to put it. At one point in time, I never had a choice. I know it's just one place, all the water is going to go. But this time now, I'm able to water the front, the back, the side. So because the banana is not getting as much water as they used to get, two of the banana shoot, and one of them muggle like me, and like a breeze blow, you know what happened?
Yeah.
It pop into, yeah, because remember, water is what really holds it up, and give it its strength, the bananas. So because it wasn't getting as much water, two tools, breeze blow, boom,
A lot of water.
yeah, it just break. It broke. It broke into. I just said to myself, the truth of the matter is, me want to plant you. Father God decides whether or not you can bear or not to bear. So I'm not even going to get upset. But yes, it's very important. We have to stress the importance of recycling. But sir, I live in an apartment, and whatever else the situation is, no problem. Make sure, say if you live in an apartment, you have a little balcony. We can go and you can do the stuff. And even so, um, if you want to conserve, your rinsing water can actually be used for the next load, washing load. So you rinse it something before you put them in a dryer. You rinse it, you harvest that rinsing water, and you use that same rinsing water in the washer to use to wash the next cycle. Right? So we have to learn to conserve because we're in a crisis. Anybody see where I'm going with that?
Yes, sir.
Trust me, we're in a serious crisis. All right. So, so water vapor is the primary form of atmospheric moisture, right? So water vapor is the primary form of atmospheric moisture. And remember now, the atmosphere cannot store this water vapor. So it just don't stay in the atmosphere like that, right? So when it gets there, it it is the it helps to form um, dew, frost, fogs, cloud, and some levels of precipitation. You never wake up in the morning and see the whole of the car just wet up like dew, like it
The
rained.
leaves.
That's dew. Um, one of the things that I like, um, and funny enough, I can just take a early morning drive out, say to Ocherios. I don't need to go beyond Ochi, and and just look and just look at the fog, and especially when you get into Linstead, when bog walk going into Linstead from Kingston, bog walk into Linstead from Kingston. There's a section on that road, people, the old road, where if you know my job, you think it's snow, and you have to be careful. No, it's because I know how them people drive bad, and them love to overtake because it's a nice long straight road. My bright beams are on, my flashes are also on, and every now and again, I'm touching my horn, trying to alert the other motorist on the opposite side that, hey, something is here. Because God forbid, like what happened yesterday in St. Thomas, where the two taximen had head-on collision, right? Because of pretty much the same thing. Two of them coming on the corner, one must never expect the other one to come because both of them are actually breaking the use of the road. Boom, head on. News said two died. Just call a friend who lives in the parish and they say it's not two, it's four. Right? Serious matter. So the water vapor is important. It's important, right? As it's important in the formation of my moisture supply for dew, for frost, for fog, for clouds, and precipitation. Where do you think the water vapor is confined? I gave you the different layers of the atmosphere. Where do you think the water vapor is confined? What layer do you think it's confined in? And I want you to think about it. It's not a trick question. Think about all that I have said to you just now, and then you should be able to understand what is happening and answer the question. Which of the layers of the atmosphere you think the water vapor is confined in? Hello?
Thinking, sir.
Okay. Hello. Is it me you're looking for? Hello? Hello?
Or
Hello?
would be the mesosphere or the sphere?
Huh?
I'm thinking either the mesosphere,
The mesosphere? All right.
mesosphere.
So you're thinking it is a mesosphere. All right. Benika, what do you think? Is Alicia still with us? Or she gone? So you're saying the mesosphere? Anybody else want to hazard a guess?
Or the stratosphere.
Sir, the mesosphere.
You're saying the mesosphere. Okay. Venika, what you say?
Or stratosphere.
Sir,
Mm.
Or just not the stratosphere.
Oh, you're
what you
asking me if
said?
if it's a stratosphere?
Yes.
All
Oh,
right.
sir, what was
As soon as Venika answers,
Yes,
I would
sir,
say
what were you saying?
I'm
Because
asking you where you think the water vapor exist.
where the clouds are, the stratosphere?
The what?
A stratosphere.
No, the troposphere.
The
Troposphere. Troposphere.
troposphere?
The troposphere, yeah.
Oh,
So it,
stratosphere. Oh,
right. So it has to be the troposphere, guys, because you remember that's where that is the part that is closest to us. Something like what 0 to 10. What did I give you the last time?
Oh yeah, the 10 or 16.
Right. So it has to be the troposphere because remember, the higher you go into the mesosphere, the stratosphere, you know, or the thermosphere, remember, it's closer you're going to the sun. So all of that will evaporate out. Is what I'm saying?
yes, sir.
So the water vapor have to be in the coolest part of it. And the coolest part is going to be the troposphere. So let's think back at it now. That
Yes, sir. There's a
we
mix up
cannot say it
with
again.
the so it was a mix up based on the type of cloud,
Right,
stratocumulus, and the that's but the topo. Yes, sir.
right, right. But think of it now. So remember now, if if by extension, if the ozone is broken and we have dangerous rays coming in on us in the troposphere, it's what will happen. We're not gonna have no water molecule because it's gonna just evaporate all of that. So it will cause
Yes, all
more
right.
harm. Yeah, much more harm. All right. Okay. So the
I just
transition
pop up
process.
the screen again
Okay, sure.
and talks.
Mhm. So the transition process from the vapor state to the liquid state is going to call what?
Precipitation
Okay.
with vapor to liquid,
Mm-hmm.
condensation.
Condensation. All right. So this is going to take place as soon as the air contains more water vapor than it can receive from the free water surface through evaporation. All right. And and then now the water vapor in the atmosphere is going to release to form precipitation. All right. So you can have condensation. It's going to stay there until it becomes concentrate. And incidentally, you remember I spoke about my black skies
Yes, sir.
condensation, right? And then now um you can have the precipitation that comes down now in the, let us look at the diagram, in the form of rain. So if you look at the diagram, you can see the clouds here, condensation. And then the precipitation here can come down as your rainfall. And then you can have the rainfall that does quite a number of things. Quite a number of things. So we talk about your evaporation or transpiration and evapotranspiration already. And it goes into the clouds. When it becomes condensed, um, clouds full, now have nowhere else, can't hold no more, it start to cry. And in crying, we can have the precipitation, right? Then it comes down now as surface runoff. Uh-oh, surface runoff, sir. But while it runs off, it is going to infiltrate the soil. What it's going to also do is to recharge our groundwater table or groundwater reserve. All right. And then the groundwater is going to, flow into our rivers and streams. And in that process, we have the creation of alluvium. Anybody know what alluvium is?
Would that be like some form of sediment or something?
Some sediments here, like siltation,
Oh, okay.
and which is what exactly is happening in our dams, because we have a lot of landslides and we have a lot of land mass movement. What happened is the water that goes into the reservoirs contain silt, and after a while the silt solidifies and becomes calcified, and it becomes it tough like rock, literally tough like rock. Good rocks told me I talk tough, So it's not that you can just use like a shovel to just shovel it out, or no, man. So you have to go, really get it out, and the guys now decide, well, the plant is dangerous, because when we try to cut this siltation that built up over the many years, we can crack the dam. And if we crack the dam, so Jamaica in one drought because we don't have no other dam. So that's why we're having this restriction over the years of water lockup. And it is annoying. I live in an area where you have water lockup, especially when it rains. And that's the irony of it. When it rains, oh dear, we're not going to have no water. So you have to find ways of storing your own water. I remember there are times when every container in my house that could hold volume was filled with water. My counter space at one point in time wasn't counter at all, because I had to do. And one day I said to myself, nah, this thing don't make no sense. And then I decided that I'm going to invest in a couple tanks. Because if I don't do that, I'm going to be in problems. As we speak, I have no water from the pipe, that is, from the source. But I have stored water. So if I go to the bathroom, if I go to the kitchen, if I go outside or anywhere, the laundry room, I can get water. But the water that I'm going to be using is actually stored water. All right. So it is very important that we do the things that we ought to do, so that we can have this precious commodity um, for our use. So the water that goes into our groundwater reserve gets discharged back into the streams, and the process begins again. Evaporation, transpiration, evapotranspiration, right? So you can see that sort of cyclic process that takes place. But let me have a further conversation with you. to let you know that precipitation falls to the earth is distributed in four main ways. The precipitation, the rainfall that falls to the earth is distributed in four main ways. One, some of it is going to be returned to the atmosphere by evaporation. You ever see rainfall and sun shine it?
Yes, sir.
Oh,
Yeah,
yes,
man.
sir.
When I go to school, them say the devil and him
It
wife are fight.
light it over, girl.
Yeah. Right? So that's what happened. So while it rains, it sometimes, sun is shining. So we have evaporation taking place. So one of the major main ways is some water is returned to the atmosphere by evaporation. Some may also be intercepted by vegetation and then evaporated from the surface of leaves. Remember we talk about the transpiration right there, so?
Yes, sir.
Mm-hmm. So some of the water that we have, not going all be caught, and some going to be taken up by the roots, and the water is going to travel up to the stem, to the leaves, and then evaporation is going to take place from there. All right, so that's two. Similarly, some of the water will percolate into the soil by infiltration, and the remainder flows directly as surface runoff into the sea. Be reminded though, when you look at the diagram, that some of the infiltrated precipitation may later percolate into the stream as groundwater runoff. Very important. Very, very important. All right. Now, most groundwater is derived from the precipitation that has percolated through the soil. So most of the groundwater is really derived from,
Percolation.
say it again?
Percolation.
I don't hear you. You don't understand what I mean by percolation?
Yes, sir. Yes, sir. Must say what I say a while ago.
Oh, you agree with me?
Yes, sir.
Okay, good job. Yeah, man. So, so our groundwater is actually recharged by the percolated, movement of the water through the soil. Um, and this it does so the recharging of the groundwater. Um, there is no there's no specific time frame. It can it you will recognize that the surface water will run at a faster rate than the recharge of the groundwater, don't?
Yes, sir.
Yeah, because it depends on the type of soil that the water is going to percolate through. If it is sandy, sure, it is going to percolate through quickly. But if it's clay, Jesus, it takes quite a while to get through, right?
Mm-hmm.
Yeah, man. Now, the final thing that I'll talk to you about is ice. This also plays an important role in the water cycle. Ice and snow, right? Because these on the Earth's surface occurs in various forms, such as frost, sea ice, and glacier ice. So when soil moisture freezes, ice also occurs beneath the Earth's surface, forming, um, you know, we call permafrost, um, and it, you know, about some data saying 18,000 years ago, glacier ice caps covered approximately 1/3 of the Earth's land surface. They're approximating out to about 12% of land surface remains covered by ice. The truth of the matter is, um, Jesus never want me down on them place here. Same say you getting born in a Jamaica. But in a nutshell, that's what the water cycle looks like. And of course, you see your bedrock to the bottom left, bottom right. And yeah, so think about it. The water that we have on Earth is pretty consistent. It's just the distribution. Surface runoff can get a greater portion of the water than you can have the infiltration to recharge our groundwater reserve. Um, to the precipitation that comes down, to the evaporation and the transpiration and the evapotranspiration that takes place. But pretty much, you know, it is what it is. It is what it is. Do you think you have an understanding of the water cycle now?
Yes, sir.
I
So,
would I would have gone through as best as I could
mhm.
um, with the water cycle. No, there are different types of water cycles out there, different drawings of it, but this I find to be good
Yes,
enough.
sir. Very
Yeah,
detailed.
detail. Yeah. So you can see what is really happening. All right. Um, it's now 8 minutes to. I am gonna pause here for the night because I know it was expressed to me by one student of the class that they wanted to be a part of the symposium. So I'm gonna give you these 8 minutes to see if you can even just go and catch a piece of the symposium before the start of your other class.
Yes, sir. You can tell us quickly about mid-semester and the other coursework.
I will message you in the group and talk to you about that.
Okay.
All right, sir.
Cool. Take care, guys.
Same to you, sir.
Yes.
Mhm.